today to present Thomas Van Tschammer of the Swiss startup Neural Concept and Brad Rothenberg of nTop. Both of them actually are located in New York, but next time they'll have to be in the same office, I think. How are you guys doing today?
Very good. Good to see you.
Very good.
Thanks for having us. Yes, we realized this morning we're both like a couple blocks from each other. So if you want to pause it like 20 minutes, we probably could be in the same room. But
next time we'll do a follow up and we'll do that.
We should.
Well, why don't you guys introduce yourselves? I think that a lot of people have probably heard of nTop and Neural Concept, particularly the announcement in December of the 100 million from Goldman Sachs was a big deal. But maybe introduce yourselves and introduce your companies before we dive into the questions.
So Brad Rothenberg, CEO, founder of nTop, and we're a new modeling tool for our customers to basically build very high fidelity parametric models very, very quickly. And given today's discussion is around AI, I don't think of nTop as like an AI app itself, but I think of nTop as AI infrastructure or underlying modeling technology enabling AI. And so exciting to talk with you guys today. And me and Thomas have known each other for years now, and finally starting to get some really good work together in the market. So excited to chat about that.
That's totally awesome. How about you, Thomas?
Yeah, thanks a lot, Michael, for the invitation. So Thomas Van Tschammer, I'm one of the co-founders and managing director for the US of Neural Concept. Been in Switzerland for the past 10 years, background in mechanical engineering and computer vision originally. And about 2 years ago, I moved here in the US, so neighbor of Brad, to open up the US branch of the company and build the team here. And about Neural Concept very quickly. So we are a pioneer and leading in the field of AI for engineering design and product development. So we bring that intelligence layer on top of the traditional engineering ecosystem of CAD, CA tools. And as Brad was mentioning, with the goal to speed up design cycles, reduce time to markets, and really unlock the next level of product performance for large engineering organizations.
That's awesome. Yeah, so you guys are both really focused on the enterprise market and not the SMB market, which is interesting. So back in, if we look back to, November 2022, there was quite the pivot point, right? There was a turning point in terms of suddenly the normal Joe knew something. There was something called artificial intelligence that was going to change his daily life or her daily life. There was also a lot of skepticism and also bullishness on different people, right? So I was interested in the two of you, like, were you guys more bullish on, the possibilities of how LLMs and this kind of conversational AI was going to transform engineering, or were you guys a bit skeptical and kind of wait to see? I was just interested in that. Either you can pick that up. It's okay.
I was going to say, Hugo, I mean, was it really 3 years ago now?
I know, really, right?
It feels like 10 years or something like that. But
well, ever since COVID, everything feels like a decade, right?
Yeah. So, I mean, I think when the LLMs broke out, I mean, we had been looking into AI since the earlier, like even when I was in school before nTop, we talked about neural networks and AI. And I think we were always, or I specifically was always bullish on the potential of AI. And I think what happened when the LLMs entered the market, it finally became like common knowledge to everybody that AI was here. It's not a fad. It's going to have an impact, and it has an impact on just like normal parts of everyday life. It's not just like something that's a high-end tool that people use. And so I think at the same time, there was also a lot of these like really silly like text to CAD demos that were coming out with the LLMs, or like code, we have CAD as code and we're going to hook an LLM up to that and generate geometry from that. And oh my God, we can make a bracket with 4 holes in it. Like, holy crap, this is like going to revolutionize the world.
Yeah.
At the same time, I was thinking, with nTop, the entire nTop model is backed by a directed acyclic graph of operations that's represented in like a JSON format. And LLMs are really good at reading, editing, modifying, generating those. And so we were experimenting with that too and found some pretty interesting use cases of having an AI kind of co-pilot or partner with you in terms of helping construct, edit, tweak, modify an nTop model. And so I do think at the time, what I was really excited about was actually that, like, okay, we're a new piece of engineering software in the market. The legacy tools have 30 to 40 years of features built on top of traditional boundary representation technology. And to me, AI is like, okay, this is an accelerator. All of a sudden, AI could accelerate building a complete feature set around an implicit model that nTop is built on, so that you can build sheet metal components, you can build injection molded components, you can design airframes that are, with traditional machine bulkheads. And so I think the transition to AI, is essentially the new thing. If you look back in the history of engineering software, one design cycle on the drafting boards in the 60s probably took, a couple of weeks. With CAD, you can reduce that to a couple of days. With AI and nTop, we're seeing you can now reduce that down to minutes. Or you can run, if you have unlimited compute, you can run hundreds of thousands of different variations on a design to understand exactly if a certain aircraft is going to meet a certain mission requirement, in minutes. And so it's really, to me, it's an accelerator.
You might need a nuclear power plant to do that next year, but
yeah, or our customers making turbines to power it.
It's incredible.
Exactly.
It's amazing.
Yeah,
What about you, Thomas?
I would definitely relate to what Brad was saying, right? So Neural Concept, if you think about our company, we started in 2018, and before that, we were doing research in computer vision, which is a class of AI models. So we are relatively old, if you can call it so, right, in the industry and for AI in itself. So we were there way before LLMs were even a thing, right? But because of that, we were always convinced about what this can bring to the industry, right? But as Brad was saying, way beyond just superficial, text to CAD or LLMs that you just plug in an interface and hope for the best, right? Because engineering requires a whole other level of details and has different requirements. So it's not that simple. But really, in 2022, what happened is that it shifted the mind of people because they also realized the potential of these approaches for engineering as well. So we really switched from conversations with executives in the engineering space where they were asking if AI is a thing, right, to how should I be implementing AI at scale within an organization, right? And we really saw that difference in their mindsets. And then similar to Brad, what we saw is that we, as modern companies, AI native companies, we are extremely well positioned to leverage the capabilities of these LLMs, right? Similar to nTop, our platform is based on Python. LLMs are extremely good to interact with code, right? So what we're saying is that it can accelerate drastically the development of these AI-driven workflows using these LLM agents on top of what we've built, right? And just earlier this year, we've announced, these design copilots, which is this LLM layer sitting down on top of our existing platform, where we give this geometric and physics context to these agents.
Awesome. Well, we're going to get to the integration of the AI into your products in a moment. But even before that, I was thinking too, it's interesting how two of the biggest revolutions were just having one line in the middle of the screen, right? Google, well, the first thing you saw was just a line where you could type in, suddenly search the internet, and now with the LLMs, it's kind of interesting how simple things are become so incredibly powerful. How has AI changed the well? Let's say, how have the new things like what Cursor was so 2024 now, right? But how is nTop and Neural Concept using AI in the development of code? I mean, is every single developer using Claude Code or some kind of code pilot? How are you actually integrating that? I'm sure it's been a total revolution to both of you guys in terms of how developers work on a day-to-day basis, right?
Yeah,
you can pick that up.
Definitely.
Go ahead.
Yeah, definitely it has. Now we have embedded best practices using AI at the core of our software development process, right? So every single engineer in the team has access to these agents to support their development, right? all of that is centralized into a global source of knowledge that everyone can rely on as well. So for the code, this is the lowest hanging fruit and the first application that we've deployed very rapidly, and now we're using at scale, right? But this goes also beyond just code, right? We use that also for the different teams, marketing, go-to-market, to build different strategies and others using custom agents that have access to all our documentation, all our material internally at NeuroConcept. That allows also new people to ramp up much faster, right? We are in a phase of very fast growth at NeuroConcept.
Of course.
And we're seeing that these agents are incredibly powerful to share this knowledge with new people joining the team and make sure they can get up to speed much faster, because they have basically someone next to them to whom they can ask these questions. And this agent has the full context and the full history as to what the company has been about.
Yeah, I mean, I think that's kind of the thing where it's like almost most impactful. Like as you're ramping up in a new job, you want to just ask somebody next to you, like, hey, like, how do I do this? Or where do I find this? Or where do I get this? Or if you're learning nTop, how do I do this? Like, hey, I want to, parameterize up a 2-panel wing. How do I do that? And having an AI agent that you can just ask and do that doesn't distract somebody else and break their flow of doing things. And so we see a huge benefit there. And same thing with Thomas, like our dev team is kind of unified around Claude Code. Some people use Gemini as well with both of those tools internally. But what's amazing is just how much the tools continue to improve. Like they're accelerating. Even in the last 3 months, Claude Code is exponentially better.
Oh, it's insane, right?
Than it was a year ago. And, it continues to improve, whether it's like for each pull request, having an agent that can review the pull request when there's new bugs that get filed, having an agent that's able to look at that, figure out what the solution is, et cetera. It also varies on the team, right? Like, because we have some very low level, like kernel developers, and these guys were like very hesitant or very resistant to the AI tools up until about 3 months ago, when it flipped and the dev team has been embracing it. There's still humans in the loop for all the code that gets, submitted into the code base, but it's more like a co-pilot or a co-assistant that helps with the code.
So do you think sometime you're going to have some agents showing up for Scrum meetings? I mean, is it changing fundamentally sort of are we going from a waterfall and agile, some new mode that's sort of agent powered and agents are sort of in the middle of all that?
I mean, I think if you just look at the number of features that we've been able to deliver in the last 6 months compared to the prior 3 years, it's an order of magnitude more.
Wow.
per sprint, per month, per
to your point, Michael, I don't think this would replace engineers sitting in the meeting room, right? But it will really empower them. That's what we're seeing, right? The same highly skilled engineers able to deliver much more, being assisted by these co-pilots in the development. And that's true internally at NeuroConcept, but that's what we're also seeing with engineers, right? Leveraging AI in engineering design.
Okay.
And then the other thing too is our field team that goes on site and works really closely with customers, they're also highly using AI
to capture requirements and feedback.
Yeah, well, and also just to if they have to build something new in the tool, being able to ask an agent okay, what's the best way to parameterize this, or what's the best way to structure this, or can you clean up my model? Can you clean up my file?
That's amazing.
Yeah, one of the first use case, for example, here for us as well, to Brad's point, was looking at the pipeline developed on the platform and asking, okay, what does it do, and where are the errors coming from, if there are any, that are being raised, because that's where agents are extremely good at, and that allows you to debug and iterate, to orders of magnitude faster, typically.
So it's also amazing because it seems like there's a lot less hallucination. Have you guys have you had to put a lot of guardrails around it, using GSD or Ralph Loop or whatever, or have you found that it's actually just because the quality of Opus 4.5 is just so many leaps and bounds over all the previous ones? I
mean, in the AI that's used in production, so we just did a webinar around this where we've been partnering with like the guys at Astari and Siskit, where you can basically.
Oh, that was an awesome podcast. Oh, everybody's got to watch that one. Anybody, people listening, you got to see that one. It's really good.
Yeah, well, the idea is like, how do you go from requirements to flight in order of magnitude faster? And in that workflow, the guardrails are built by a combination of humans and AI in the form of unit tests. And so in using AI in any production application, I think the guardrails are really critical, because they still do, even the latest Claude model will still like make mistakes or hallucinate. I mean, I am interested now in these like OpenClaw like workflows that are just like consistently running and always running in the back end. Like imagine like a team of, configurator, arrow guys, structures guys, propulsion guys, all working on a program, have an AI agent, and they're all doing their own work in calcs and then sending their work to the agent to basically organize, compile into reports, tell them where the bottlenecks are, say, okay, where is L over D right now compared to last rev? Like in some way, I think an open claw like workflow is almost like the next generation of PLM.
Yeah.
Like it's an active and live PLM. And I think I think this is going to be a real big change that's going to happen in the next year.
I talked to Adam Keating. He had sort of the same idea that there's going to be a fundamental change to the data management by AI. I still think we're going to need a system of record. Sometimes you still have to write it down like in stone because the AI forgets after a little while. But I agree that there's something coming. Go ahead, Thomas. Sorry.
I think what's very important here, and especially in engineering workflows, is that you cannot start from scratch. You need a very solid foundation of digital ecosystem if you want to leverage this agent at scale and productively, right? You cannot start from scratch because we need guardrails, as Brad was saying, right? All of that needs to be embedded with physics, with requirements at the core of it, right? So these models need to be able to interact with the different tools in the ecosystem, whether it's nTop and others, to be efficient, right? It's not like you use ChatGPT on your own and you ask it questions, and here you get hallucinations. You can live with it. In engineering, that you cannot afford to have that, right? So you need to have these agents living at the core of your workflow, integrated with your different tools that you're using on a daily basis, so that you can do these checks. This can be grounded in physics. This can be grounded with the requirements that you have. And this hallucination is not even a topic, right? Because it's so structured.
Yeah, I mean, you still need the same things. You need traceability. So when you see numbers in somewhere, you need to know, where do those numbers come from? Do those numbers meet the requirements? Where are they coming from? Why are they coming from? And you need, associativity and parametrics, right? So you need associativity. So numbers are related to other numbers, or data is related to other data. And you need parametrics. So like when you make a change somewhere, that change is able to flow through the process. Like if I, change my engine from a 50 horsepower engine to a 75 horsepower engine, how does that change flow through to the design?
There's good, more empowered digital thread, which is really where AI is going to be super important. In fact, David Bigelow, one of my friends, just commented that elevated spec-based development is the future. He thinks MBSE may raise its head in the future to help structure this. Well, I think that's what Ciscus is doing, right? Ciscus,
well, I mean, I think this is the thing. Like
TraceSpace are doing that.
The systems engineers always were kind of separate from the design engineers. And they were like a different layer, where like the design engineers would work on the 3D model, which in my opinion, no offense to the systems engineers, is the source of truth, right? That's the 3D object. That's the real engineering. The real engineering happens. The systems engineering definitely represents the architecture of the system. And I think in the past, systems engineering was thought of as just like elevated box diagrams representing an architecture. And I think actually what's going to happen is the systems engineering is going to become directly integrated, connected to, reinforced by, and interacting with the 3D. And you're going to have this connection between the two. And I think there's Siskit. I think Pari at Flow is doing really interesting stuff on the
trace.space as well.
Yep, on the systems modeling. And I think there's going to be a real digital connection, like a real interlocking of the systems tools in a way that doesn't really exist between like Cameo and CATIA, for example.
Right. Well, actually, I would direct this at Thomas, but I was thinking too that one of the transformations that AI is making in engineering is it's bringing all of these things that were separate disciplines all together, right? Because it used to be you had, as you just said, Brad, you had the guy that was doing design who had no idea, who didn't even care who the systems guy was. And then you had these simulation guys all the way on the other side of the campus. Oh, and even worse, you have the manufacturing guys who we would never talk to in a million years.
Yeah.
And now all those disciplines are coming together, right? A manager has to be thinking about design for mission, design for sport, and all that stuff, right, Thomas?
Yeah, we have a very good example that to illustrate that. It's typically aerodynamics for car, right? In the automotive industry, the aerodynamics, it's not a purely an engineering problem because you have the aesthetics of the car that come into play, right? And how are companies working together today? Well, you have the design team, the studio team on one side, you have the aerodynamics on the other side, right? The studio teams comes with requirements or suggestions. The aero, they have to very quickly get those iterations through and try to give some suggestions back to the design team. And you have this back and forth, right? Which is today a major bottleneck. If you want to have a nice looking car, that's aerodynamic, right? And what we're seeing, to your point, Michael, but then that goes across many more disciplines, is that we're bringing those teams together around the same table, because now they're able to iterate together in real time, and then move from intuition-led iterations to data-informed design decisions, right? And that's a big, big difference. Now they're able to explore these what-if scenarios live together, that then they can make the best trade-offs between aesthetics and aerodynamics. But as you were saying, that goes across disciplines, right? Ultimately, and in the whole company. Essentially, when we talk about digital thread, right? Up to today, digital thread was a big thing, specifically in aerospace, right? Because you wanted to ensure this traceability, right? But beyond that, there was no purpose to digital thread, and this was not used to accelerate any iterations per se, right? What we're seeing with AI here is that this is giving this purpose of acceleration to the whole digital thread. So now you have a real clear incentive to build that layer, because now you can use AI on top of this to accelerate your workflows.
Agreed. I think that we still have a problem between our side and the manufacturing side, but that's a whole nother conversation, right? So let's talk a little bit more deeper about the two platforms, the neural concept platform and the nTop platform. How is AI embedded in it? You started talking about that, Brad, but like, you know, there's the co-pilot angle, right? Where you've got the guy, the assistant sitting next to you and you're doing your design, but there's also maybe using fundamental models. There could be agents, which Tom's is probably going to talk about, and how you do workflow inside an application. So how have you embedded AI into the actual application?
You want to go ahead, Thomas?
Yeah, so I mean, for us, AI is at the core of what we built, right? Started in 2019. So again, we started not necessarily using LLMs, right? But we started with models able to learn the laws of physics directly in 3D, right? So models that could ingest a 3D geometric file, typically an nTop file, right? We have a cool demo coming up soon with Brad about this. So, you know, models that could learn directly from 3D and then predict the laws of physics very quickly to speed up these design cycles, right? Then, as I was saying, our company being AI native, you know, being built on the modern tech stack of today, using LLMs on top of what we've already built was straightforward, and you know, was just a logical next step for us. So we've integrated LLM as the second layer of AI, right? So that engineers could interact with the platform, with the documentation, could speed up their developments on top of this strong base that we already had. Right. So it's more than ever at the core of what we're doing at Neural Concept.
So really the DNA of neural.
Yeah.
How about with nTop?
Yeah.
It's a little different.
I mean, I was kind of saying in the beginning, like I think of nTop more as like AI infrastructure. And so what I mean by that is like when I started nTop, the problem we were solving was how do you make a model that can be, how do you build a really robust 3D parametric model? So a model that can both capture breadth of design space. So if you have an aircraft, how do you have like a parametric model that can create a wide range of aircraft, but then also be reliable and robust and really, really fast to update. And so what's been interesting with the wave of AI is that, you know, one of the requirements for AI, whether it's building and training a surrogate model that you can use for AI physics, or whether it's an AI co-pilot helping you construct, edit, tweak, modify in the kind of more generative AI use cases, one of the requirements that that puts on the model is a model that's very, very robust and very, very fast and easy to evaluate. And so making the choice early on to build nTop on top of signed distance fields rather than BREP, you know, the goal of that was to produce kind of really rapid lights out operational models. And so what we've seen is that our model works really well when connected to a traditional, one of the foundational LLMs in terms of editing, tweaking, modifying the model. We also have a product that's called nTop Automate, which is basically the lights out version of nTop. And we've built that can be deployed via container. You can wrap an agent around that that can act as your nTop co-pilot. So if you, as a human, are making edits to an aircraft model and then immediately want to like run thousands of variations of that, you can send that model up to Automate, have Automate deployed in a cluster of thousands of machines and have it produce and process and generate, you know, infinite variation on that model with the performance checking. We also have a really robust lower speed CFD solver via nTop fluids, but we have really, really solid workflows for going from nTop models into the different physics that you would need for hypersonics applications like with Vulkan and Fun3D, or other applications like Star CCM, Fluent, etc. And so the areas where we like, again, I see nTop as a AI enabler rather than like just an AI app. And so all of the tools that are building AI applications we're partnering with or we want to partner with.
Right.
Whether that's on the physics AI side, whether that's on the generative side as well. So
Well, do you think
it's been really exciting to see this? And again, there's like a number of new startups in the space, whether they're building kind of generative AI or whether they're building, you know, physics AI models like MEAI, PhysicsX, Pastor, these other companies as well. And you know, super excited about the work we're doing with Thomas and the team. You know, we have our nTop Summit coming up on April 21st. Thomas will be there. We'll be talking about some of the stuff we're doing together. And, you know, if you're interested in joining that, you can register on our website.
Awesome. I was actually going to ask that at the end, but that's a good lead into the where we can see you guys.
We can say it again at the end also.
Of course. No, it's going to be good. I wish I could go. I'm just too far away from California. So do you think that we're going to see the emergence of well, let me go back. That I would rephrase and say, when do you think we're going to have the OpenAI moment for engineering? Like when is there that pivot for that, or the what's the word, the tipping point? Where's the tipping point where engineering becomes we have that transformation that as big as the 2022 moment for LLMs? When does that happen for engineering and design? Are we there? Are we not there? Are we a year away? Are we 10 years away? Just wondering what you guys think. It's sort of the end of this section, you know, in terms of we're now 4 years into the revolution. We've gone through MCPs. Now we did the open cloud, whatever that was. When do we have the tipping point? When do we have our OpenAI moment on the engineering side? Sorry, go ahead, Thomas.
Today, I would say today we have the tools to do it, to be there, right? Definitely. What happens is that we, you know, as an engineering company, you've been building cars or planes the same way for the past 30 or 40 years, relying on tools based on, you know, the legacy stack, which makes it hard for you, and there is inertia to adopt these new tools at scale, right? But today, with what we're seeing, there are all the tools that you can bring together to have these aha moments in engineering design, right? We have many applications where, you know, the company is using the NC platform to run designs, large design campaigns, explore way beyond what they could do normally. And then the engineers, they see the final design and they have to even try and reverse engineer the design to try and understand why it's so much better than what they have been able to do in the past, right? Because it goes beyond anything they could think of, right? So I would say we are much closer than we think, but we need to bring all the pieces together. And in engineering, in a highly constrained environments, we need to do that carefully, which is why it also takes time.
Yeah, I mean, I was on site with a mutual customer between nTop and Neural, and it was amazing to see it was almost like seeing the neurons cross when I saw a demo of how they were using Neural and then how they were using nTop, and the customer was like, wait a second, these need to be connected together and we need to be running these models in the, from the Neural platform and training models and bringing them back into nTop and creating new parameterizations in nTop and running and training and organizing and generating new variations. And I think I completely agree with Thomas in that the tools are there. I don't think there's going to be like a ChatGPT moment in engineering. It's just the nature of engineering. Like we have products that are in production today built on processes that were developed in the 70s and the 80s. And I think just like if you look at how composites entered the aircraft industry, right? Like you wouldn't think twice about designing a new airframe that's a composite structure today.
Right.
But like 20 years ago, that was a really hard thing to do. And even though we could build composite structures in the 80s, I think was the DARPA program.
And to your point, Brad, we are seeing a very big difference between what we call the digital native companies. So, companies building hardware, but that started, maybe 10, 15 years ago, and the legacy ones, right? The pace at which these digital natives are able to adapt to these new tools is very impressive, right? And I can tell you that from what we're seeing in the industry, working with these companies, they are much, much closer than we think to a real AI native experience.
I couldn't agree more. I mean, if you just look at the way like Blue Origin and you look at the way that Spectre, which are both public about how they've been using nTop, how they're using nTop, it's unbelievable what they've been able to do with fairly small teams, where like in the past, it would take 100 engineers to generate 100 concepts and then 1,000 engineers to do the detailing on one of those concepts. Now you could have one engineer produce thousands of concepts and a small team of a couple engineers do the full detailing of that concept.
So sort of the possible design space has just gone bigger.
Yeah, and what's amazing is that this is in the US, and I mean, I know Thomas is seeing this because of mutual customers that we work with. Like there's this like revolution happening on the defense side where like, for years it was all about consolidation into like the 4 primes. And in the last couple of years, you've just seen this explosion. We've seen this massive explosion of like new defense startups, which are these,
and you're real,
pretty tight teams of engineers that are just like grinding really hard with the right tools, and they're able to produce pretty amazing new products with small teams. I think
Mike, Brad knows that even better than me, I guess, but Mike, you'd be amazed by today in the engineering industry how designs are mostly led by intuition. It's today, how do we design and how do we iterate? It's an engineer that, based on years of experience, and a very skilled engineer, will say, okay, this should be how the next design look like to improve the performances. Right? We are still in traditional industries very far away from these data-informed design decisions, right? But as soon as you're able to unlock that, you unlock a whole new level of performances, right? Because you go from one iteration, which is based on a static parameterization and a few design variables, to now a space of design option which is almost infinite.
Yeah,
and we're seeing the shift.
And I mean, I feel like I've been seeing the future over the last 2 weeks of how engineering gets done.
Nice.
Like I've been sitting in. One of the things I love the most is like sitting in design reviews with our customers and just seeing how design reviews get done. And I'll kind of give a couple stories. So like a couple of years ago, I was sitting in a design review with a customer that was just picking up nTop, and they were working on some component parts integrated into the wing of an aircraft. And they were all sitting around this CATIA model of the component that they wanted to modify. And you had like a couple of subject matter experts in the room arguing for an hour and a half, how they should route certain tubes. I don't want to say like too much about it, but how they should route tubes through this structure of the wing. And they were basically just arguing for an hour and a half, spinning a model. In the last 2 weeks, I've sat in design reviews for like a group 3 drone, so like 1,000-pound class drone, a group 5 drone, so more like a F-16 size drone, and then also a hypersonic vehicle. And in all 3 of those design reviews, you had teams of like the entire design team. So you had aero people, you had structures people, you had propulsion people, you had the weights people, you had the GNC people. And, you know, they all have their own responsibilities, right? Like the aero people want to make sure that it's going to fly. The GNC make sure it can fly stably. The structure people make sure it doesn't fall apart. The propulsion people make sure it can go fast, right? The weights people make sure it's balanced and the CG's in the right place. And in all 3 of these design reviews, they were all sitting around nTop models and they were asking just as many questions, but as soon as they would ask questions, people operating nTop would make those changes and immediately they could see the impact of those questions. And so it was really like a live data-driven process. And they brought back a data set from like the night before. And these teams are running like 20 to 50 new revs a day on a model. And in some cases, looking at that data set in Neural and seeing how that can be done. And I think like, as you integrate what Thomas and the team are doing, you now get that additional level of fidelity in terms and confidence in the predictions as you're making changes to an nTop model, immediately seeing like, oh, well, if I, you know, change the fineness ratio of the fuselage, I'm gonna lose some fuel, but I'm gonna have less drag, and I'm willing to take that trade in this case, or maybe I'm not, you know. And so I think that to me has been, I feel like I've seen the future, and I want to get this story out more on how these amazing teams are working, because they're moving really, really fast.
Well, thanks for sharing that. In fact, I feel like I asked you like a pretty provocative question. Is what's holding us back from that tipping point? Is it the legacy software? Is it all that CATIA and all that 3D experience and the NX and Creo, and not enough use of Neural and nTop? Or is it more psychological, more people? Like we're used to doing things a certain way,
it's the legacy,
and it's going to take a while.
I mean, look, I started nTop because I am obsessed and love CAD software. And so I don't think CATIA or NX are the bottleneck. It's just these tools were developed for highly detailed design once you know what you're going to make, and adding all the attributes, keeping track of stuff in PLM. Like they're really, really amazing tools for that. There's no better software on the planet. And in my opinion, there's no more impactful software on the planet than traditional CAD software and the simulation tools built on top of it. And so I don't think those tools per se are the bottleneck. I wish I could just be like, yeah, all those tools are the bottleneck and everyone should just like switch to nTop and Neural and like that just will save the day. But I don't think that's the case. I think it's understanding when to use the right tools. And I think the reality is most of the products that are out there today that new engineering is being done on are not like brand new. And so they've been built and developed on top of new processes. And so the time it takes to learn and integrate a new process, there's the perception that there's not enough ROI to do that. So people are not going to change their processes. And I think the way we've addressed that is set up our design sprint program, where we'll send in our field team that can help produce the outcomes that customers want, or show the outcomes that customers want without them having to like train up and learn the new tools. And at the same time, we have a really strong education program. So Matt Mueller, who's in the other room right over there, he's our education lead. And when nTop is taught within the schools and everybody comes out with just like pure native nTop skills and Neural skills and CAD skills, I think that's where you'll see the transformation. I don't think there's one, like I said earlier, I don't think it's gonna be like one moment where all of a sudden, holy crap, like the ChatGPT moment. I think it's going to be more like, whoa, that happened really fast. How is every new system
Be more
starting
retrospective than
Yeah, exactly. Like, how did that because it's engineering is such a large and slow to change, which makes sense. It should be. I don't think I want like to know that the engineers at Boeing are just like trying every single new tool and moving that into production on the plane that I'm flying to LA today. I want that. I want to know that that plane, I want the most boring possible flight.
Right. I think that's also where we have a mission. I think you said it, as companies, is on the education, right? Because we have, as you were saying, I'd love to be able to share with everyone out there what we're seeing on the field, right? Because this is truly impressive, right? But then it's also our mission to educate, to upskill these engineers, to explain, where we believe each tool fits, right? And so I should have Matt from our team, who is our head of engineering enablements, meet with your guy, right? Because I think they have the same mission.
100%.
Also based here in the US. To your point as well here, it's really a matter of identifying which tool fits where, right? One of the questions we are often asked in the initial meetings is, okay, you guys are gonna, replace simulation. It's because why would we need simulation if we have AI models that can predict physics right away? But actually, what we're seeing, it's not true, right? Simulation will always stay when you need these high fidelity results to take the final design decisions and tweaks. But you will use simulation in a much smarter way. It's when you know that you have a much larger freedom to explore. That's where you want to use these accelerated design loops, right? That will then direct you towards the right design to simulate and then to prototype. It's the same shift that we've seen with simulation and prototypes 40 years ago.
Okay. So before we shift into the last section, I wanted to ask just a question because the demographics of my audience.
I've actually one quick question, just to like a thing, like, is there a world where we do, like, I agree with the shift from like, the shift to using traditional finite element solvers and the shift to using CFD solvers versus wind tunnels. We still use wind tunnels today. It's not like wind tunnels disappeared. You know what I mean? And I think that same shift is we're seeing from, if a wind tunnel test costs $1 million and a CFD run costs $10,000 to set up and run, an AI run, once you have assuming you have the model trained, might cost a couple dollars to run. If it's another order of magnitude speed increase, like, is there a world where the traditional CFD tools do go away and everything is just AI based? And my answer to that is I don't think that's the case, because I don't believe that there's like one super AI model that's just gonna like beat everything. But I'm interested, Thomas, in like if you think there is a world where that stuff goes, because I'm sure people ask me that also, just the same way people ask you that.
Yeah, no, I don't believe so, at least in the short term, right? I believe we will still need to rely on simulation, as we still rely on prototypes today and wind tunnel, right? So wind tunnel hasn't gone away because we want to do these final checks, even though we have simulation. There is a very famous sentence that says, all models are wrong, but some are useful, right? I think it very much applies to CFD, for example, but now also to AI, right? The question is, where do you want to use them? Where should you be using them in your design workflow? But what we're saying for sure is that while it won't replace fully simulation in the short run, it will drastically reduce the need for it, because you will not run blindly simulations anymore. But whenever you run simulations now, it's for a very well-targeted purpose, or final validation, for a final tweak that you want to run, right? So you know why you're running it, because these are costly simulations, these take time, right? So every time you do one, you want to do it with a purpose. That's the shift.
The other thing I love the idea of is, like, if you have a neural model set up, if I send some nTop geometry into the neural model, you could tell me how accurate does this model fit within the space that this model represents. And if it's outside of the space, just upgrade that to run high fidelity CFD on that model. And now
exactly.
And your surrogate model. And so I think that
exactly
that way of working to me is like the ideal way of working.
Today these loops are automated, right? So it's exactly what's happening, right? So the models, they have a way to tell whether they are within their boundaries of knowledge, if you will, right? And if they don't, we can automatically trigger a high fidelity simulation, recalibrate the model on the fly. But all of that can and should be fully integrated. So that's why we're talking about this mature digital stack that needs to lie under these tools.
So I was starting to say that the demographics of the people that watch this podcast, there are quite a lot of younger engineers or people that are still, haven't really started their career. And I think there's probably a lot of anxiety about AI is going to steal my job. I also think that startups like nTop and Neuro's Concept would rather the best engineers work for you guys instead of going to some boring job at Meta or Google, right? You'd rather have the best guys working at yours. So what should those guys be working, those women and men be working on? And how, what kinds of things are you guys looking for in the engineer of the future that's going to help transform nTop and help transform Neural?
I think more than ever for the engineers working with us in large engineering organization, you need to work on your fundamentals of physics, on your domain expertise, right? Because to your point, Michael, I think actually there's never been more exciting times to build hardware today. It's because what we're saying is that engineers now, they are spending their time on doing fun stuff, taking the right design decisions, making the right trade-offs, right? The time where you would manually set up your simulation, your machine requirements, wait for the simulation is getting over, right? But the time where you need to apply your domain expertise to understand the big picture, the requirements, and fit all of that to take design trade-offs is happening. And that's where you need this very, very strong domain expertise, grounded in physics, grounded in engineering. So if anything, for the new wave of engineers, work more than ever on the basics, so that you can be empowered using this AI tool.
I mean, I think there's nothing more powerful than somebody with really good intuition into engineering working with an AI tool to accelerate them, because they're able to see immediately and call BS when there is stuff that's wrong, versus just letting the AI run and produce something that's nonsensical. And so, but we have this internship program over the summer where we bring in interns, and their goal is to basically design, build, and fly an aircraft to a certain set of mission requirements. Matt organizes that. We're filled up for this summer. We have 6 interns coming in,
Nice.
starting in a couple months. But I think for us, it's a mix of understanding the physics, understanding geometry. Like geometry at nTop is really, really important. So being able to understand how you represent and model and create implicit surfaces is critical to nTop working and solving more engineering problems.
But I suppose that another prereq is that the engineer also knows how to leverage AI, right? You got to have the
physics. I don't know one student who is in school or graduated in the last year who is not an AI native person. I've never met them. It's like everybody that I talk to, interview, work with in our EDU program, they're all used to working with AI, used to leveraging AI, understanding. Now, it's not everyone's an expert like the PhDs that are in Fayez's lab at MIT doing, coming up with new transformer models for physics. Like those guys are doing really unique stuff. But like just in general, I think everybody in school right now is already working with AI, at least in engineering schools that we're talking to.
Incredible.
I mean, Thomas, have you ever met somebody who's we
never happened.
Yeah, we hire interns. We don't usually, a lot of people that we hire are not like fresh grads. We usually hire people that have been in the industry, but our internship program and our EDU program is where we work with recent grads. And yeah. So
you guys are working with pretty bleeding edge companies. At this point, I usually ask the 2 people, like, on average, if you look at digital maturity from a scale of 1 to 5, 1 being we're still using Excel for almost everything, and we're still using email. to I've got these agentic digital twins that are completely autonomous. I suppose you guys, I mean, most of the people I talk to, usually their customers are between 1 and 2 or 0 and 1. I'm wondering, I'm thinking from what you're saying, a lot of the companies you're working with are pushing past 3 towards 4 already, but or not. So so the first question, because there's 2 parts. The first question is, where do you see the customers today? Where do you see the market? Are your customers between 1 and 2, or are they pushing past that?
So good example of this is we're working with the customer, and early on they were like, you have to integrate nTop with our custom weights tool.
Okay.
Had a name, and through meeting after meeting, they were like, yeah, you got to integrate with this weights tool. Our team has this. This is the tool that like makes us successful. And when we finally were on site integrating nTop with the weights tool, it was basically the biggest spreadsheet I've ever seen, with so many worksheets. It looked like you couldn't read any of the names. There was like thousands of worksheets. It had like thousands of parameters that you can feed it to come up with the optimal weight. And so I think that's where most customers still are.
So still at 1 or 2.
Yeah, I would say so.
Too, Thomas?
Even though we see a big spread between different types of industries, right, and companies. Right. I was mentioning the digital natives, right, which typically have more horizontal structure. So meaning that engineering teams can take their own decisions on the workflows and tools they're using, right? So it's less hierarchical, which also allows them to be much more agile, right? So within these companies at the team level, we are seeing some pretty impressive stuff, right? It hasn't reached yet the full corporation. It's happening, but in those teams, these companies that are typically younger, right, as we're saying 5-10 years old, building hardware, we're seeing at the team level, maybe to your scale, Michael, maybe closer to 3 at the moment.
So my thesis is that when rather than using the big 3, if customers decide to go with an nTop or a Neural instead of ANSYS or whatever, does that move the needle faster? Is using your stuff going to really push that? Is there an epiphany? People are using your tools that are AI powered, and there's an epiphany like, oh my God, if I was doing data governance correctly, if I break the silos between all these departments, oh my God, we're going to go so much faster. And is it a catalyst for digital transformation using your tools? Have you seen that? I mean,
yeah. So I mean, the first comment is, I would say it's not using NC or to Brad's point, nTop instead of the traditional tools, right? It's with in conjunction. I think that's very important because you need this mature stack to be there, and you will need it, right? However, what we're seeing, and that's where it becomes very exciting, is that we work with companies that are building their digital ecosystem today. Now in this era, they're building it with a purpose, which is this AI purpose. Right? So we are at the center of discussions with companies where they have to decide on their traditional stack, but because they're doing it with AI and NC at the core of it, they can make it with a purpose, and from the beginning being grounded with these AI-driven workflows, which makes it much, much more powerful from the beginning. It's much easier to do it from the beginning, adopting AI at the core of it, than trying to catch up afterwards without thinking about it up front.
Yeah, I mean, I kind of second that. It's not about replacing and choosing one stack versus the other stack. It's about choosing the best tools for the best parts of the process. I will say, like, where I see customers adopting Neural, where I see customers adopting nTop, they're building much more automated and lights out and kind of AI native workflows because they're able to see the benefits of doing that compared to like if they were to try and deploy like a BREP based CAD tool for rapid design iteration, right? And so I think a lot of people love to like talk about how, oh, the big CAD tools, they were built in the 70s and 80s and it's 80s technology and it doesn't work. Well, you know what? There's like really amazing technology from the 80s that people use every day to solve the hardest engineering problems out there, and it works and it's awesome. Like Vulkan, a CFD solver in the US that's written in Fortran, and it's amazing, right? And so just because something was like developed a long time ago doesn't mean it doesn't work, and doesn't mean it's bad. per se. Like I'm talking to you on Windows, and Windows has been out since I was a kid, right? Like, and I love it still. So like, I think it's just knowing where and how to deploy software like Neural, software like nTop, along with the tools that are amazing that we use every day also. And that's why, you know, for us, we have this field team that works really closely with customers to help them parameterize models in nTop, because it's a different way of working than you would parameterize a model in a CAD system. The benefit is it's more robust and faster, right? And so, and I know this way of working with customers, I think at least since we started with nTop and we were like, okay, we're going to sell you some software, we'll sell you some customer support hours, and good luck and go. And people were able to make like little heat exchangers and stuff like that pretty successfully. But now when you're really deploying nTop in an aircraft development program, it's really about how you evolve the process. It's more of a process change. And so that works really well when we're working really closely with our customers.
Awesome.
Something that, for example, worked very well for us, last point here, is we run this series of boot camps in person. We run, I think, 7 or 8 of them last year across all the regions. Next is in Detroit on April 30th, where we bring these engineers together in the same room around the NC platform, and we work together in building these AI workflows for 2 full days. Right? And that's on this education, showing them the art of the possible, understanding what's the limitation of today's tool, right? But also what this unlocks. Right? And then we're seeing super interesting conversations following these boot camps because people realize the potential of it. And then follows up with, you know, deep dive scoping session. Okay, how can I now apply this for my next generation car, airplane, engine, you know, whatever.
Awesome. Well, thanks, man. That was a really great conversation. I certainly learned a lot. It's a lot of fun. We were talking, you mentioned earlier where you guys are going to be, but why don't we go through that again? Like there's the Threaded Live, of course, in Warwick on the 25th of March and Miami on 13th of April, but I believe CD Fam and well, go ahead. Where are you guys where can people see you and meet the Brad and the Thomas over the next couple of months?
So the next big event for us is coming up April 21st in LA. It's the nTop Summit. Thomas and the team will be there also, so you can see both of us in one place. So definitely, if you're in LA or if you're close to LA or you want to get to LA, you can register on our website.
Awesome.
Which is the spot to be. Then CDDC is the next big event, I would say, and that's coming up in July as well.
And I'll see you at PLM Components, also in Cambridge, I believe.
Oh, yeah. We'll be at the PLM Components, and George Allen from our team will also be there.
That'd be really cool. Thomas, go ahead.
Yeah, on our end, we'll be I'll be with the team at GTC, NVIDIA GTC, in a couple of weeks.
Oh, nice.
So we're exhibiting there, and we have, if you guys are around or if anyone's planning to attend, you should check out the presentation with JLR, Jaguar Land Rover. Pretty cool what those guys have been able to do with us. So it's going to be exciting. Then we also will be at SAE Conference WCX in Detroit, where we've been invited for a keynote mid-April. And then, of course, the very exciting nTop Summit. Looking forward to it.
That's awesome. I can't wait. Well, I hope you guys have a fantastic 2026. Sounds like it's off to an amazing start. Thanks to everybody for listening. We had a lot of good participation, and we'll look forward to seeing you on the next podcast. Thanks, everybody.
Thanks, everyone.
Yep. Thanks.